Welcome to your severe weather analysis for Albany, Western Australia. This is your Thursday, November 27th, 2025 morning atmospheric sounding analysis. If you find this analysis helpful, please like and subscribe to support continued severe weather analysis. Looking at our Thursday morning sounding from 10 a.m. local time, we are seeing a very stable atmosphere over Albany. The red temperature line and green dewpoint line on our Skew-T diagram show minimal instability. Mixed layer CAPE is essentially zero at just 1 joule per kilogram, and surface-based CAPE is only 80 joules per kilogram. This is far below the threshold needed for thunderstorm development in Australia, which typically requires at least 1,000 joules per kilogram. The atmosphere is dry with precipitable water at just 15 millimeters, and the dewpoint depression at the surface is 4.4 degrees. There's no cap detected, meaning there's no lid holding anything down, but there's also no energy to release. The freezing level sits at 1,900 meters. The lifted index is strongly positive at plus 7.5, indicating very stable air that strongly resists upward motion. Looking at our enhanced multi-parcel analysis, we can see the purple shaded area showing the small amount of CIN, or convective inhibition, and the very limited pink shaded CAPE area representing the fuel available for storms. The most unstable parcel shows the highest CAPE at 156 joules per kilogram, but this is still far too weak to support convection. Even with forecast afternoon heating to 19 degrees Celsius, the atmosphere simply lacks the moisture and instability needed for storm development. The parcel paths show multiple attempts, but none achieve significant buoyancy. This is a classic stable maritime environment with strong westerly flow aloft but insufficient thermodynamic support for convective development. The machine learning model comparison shows remarkable agreement across all three models for tomorrow morning's conditions. GraphCast, Pangu, and ForecastNet all forecast zero CAPE and zero mixed layer CAPE, with strong wind shear around 33 meters per second in the 0 to 6 kilometer layer. The ensemble mean shows shear of 33.2 meters per second with very tight agreement between models. While the shear would be more than adequate for organized severe weather if storms could develop, the complete absence of instability means we are looking at a subconvective environment. The models show excellent consistency, giving us high confidence in this stable forecast. The hodograph reveals a fascinating wind profile that tells the story of strong upper-level dynamics without the instability to tap into it. We are seeing impressive deep layer shear of 36 meters per second from the surface to 6 kilometers, well above severe weather thresholds. The wind vector curves smoothly from the surface through mid-levels, turning from light southwesterly flow near the surface to strong westerlies aloft. The right mover star points south-southeast, indicating that if any storms could develop, they would track toward the south-southeast. Storm relative helicity is 141 meters squared per second squared in the lowest kilometer, and 286 in the 0 to 3 kilometer layer. However, with supercell composite parameter near 0.01 and significant tornado parameter at 0, these impressive shear values have nothing to work with. It's like having a perfectly tuned engine with an empty fuel tank. The atmospheric refractivity profile, shown as the blue line, reveals the vertical structure of atmospheric density. We are seeing very high-end values near the surface around 300 units, decreasing steadily with height. There's no yellow shading indicating superfraction, which would suggest strong low-level moisture gradients. The smooth decrease in refractivity with height confirms our stable, well-mixed maritime boundary layer. This end profile is consistent with our dry, stable environment where ducting and trapping of radar beams is minimal. Bottom line for Albany: this is a stable, subconvective environment. Despite impressive wind shear aloft, the complete lack of instability and moisture means thunderstorm development is not expected. Any weather will be non-convective in nature. Always consult the Bureau of Meteorology for official warnings and forecasts. This analysis is provided by Distant Curve Remote Area Telecommunications. If you found this helpful, please like and subscribe to support continued severe weather coverage for remote Australia.